first I'll give you a question for you to solve, and then we'll move ahead solving more common questions that we have. Okay. So 19th question. Uh, so this is x-axis, this is y-axis, and let us say two charges are placed. One charge is placed at the origin, which is 0, 0, and the other charge is placed at a point A, which is 10, 0.
Yes, sir.
Find, so we need to first give the charges also. So let us say here we have plus 3 microcoulomb charge at the origin, and at point A I have plus 6 microcoulomb charge. Okay.
Yes, sir.
So there are two charges placed, one at origin, other at point A. Origin's coordinates is 0, 0. Point A coordinate is 10, 0. The charge at O is plus 3 microcoulomb. Charge at A is plus 6 microcoulomb. Find the electric field, of course, in terms of I cap and J cap. Find the electric field at a coordinate phi, 5 in terms of I cap and J cap. Okay. So let me solve it. I gave the figure in such a way that the symmetry exists in this question, and it becomes easy for us. So how is the symmetry existing? The charges are different, but we have distances are the same, correct?
Yes, sir.
So because the charges are different, first I will say this: the electric field due to the charge at O at this point 5, 5 will be in that direction because it's a positive charge. So it will be away
Yes.
from the charge. Okay.
Yes, sir.
And let's say the electric field is E1. The electric field due to charge at A in this direction, let us say this is E2.
Yes, sir. Can we take 2 even?
I am trying to do it. Okay.
Yes, sir.
So where is the symmetry and how can I use it? This length is phi and this length is also phi.
Yes, sir.
So the hypotenuse becomes phi root 2,
50.
root 50, which is phi root 2. Similarly, this is also phi. So here also hypotenuse becomes phi root 2.
Yes, sir.
There are various ways in which I can utilize the symmetry situation. In this question, I am not using the symmetry in the electrostatics way per se, but rather I am using the symmetry in a very basic geometric sense, school geometry sense. What do I mean? This is a right angled isosceles triangle.
Mm.
So that means what I am saying is this angle is 45 degree.
Yes, sir.
So that means what I am trying to say is if I
That is 90.
extend these two lines, this angle comes out to be 45 degree.
Yes, sir.
Similarly, the other angle comes out to be 45 degree. Similarly, this angle also comes out to be 45 degree. Is this clear?
Yes, sir.
So what I am trying to do there is basically the vector form E1 bar is magnitude E1 into the unit vector in that direction is cos 45 I cap plus sine 45 j cap. Correct?
Yes, sir.
Similarly, if you look at E2, the vector form E2 bar, I can write it as the magnitude E2 cos 45 minus I cap
Yes, sir.
sine 45 j cap. So I'll write minus cos 45 I cap plus sine 45 sine 45 j cap. Clear?
Yes, sir.
Therefore, the resultant of these two, E1 bar E net is equal to E1 bar plus E2 bar. In vectors, we say resultant as net,
Hmm.
right? So E1 bar plus E2 bar is equal to, basically I have to add these two. Cos 45 is common, sine 45 is common. So all of this is 1 by root 2. I'll take 1 by root 2 outside. Okay.
Yes, sir.
I'll take 1 by root 2 outside. Next, inside the bracket, what do I have? I have plus E1 minus E2.
Hmm.
So here I have E1 minus E2 I cap plus E1 plus E2 j cap.
Yes, sir.
Is this clear?
Yes, sir.
See, I'll discuss again. I'll discuss this entire solution once I'm done with solving it. Okay. I'll explain the entire solution again. First, let us do what is E1. E1 is K, charge is plus 3 microcoulomb, right?
Yes, sir.
Divided by distance square is 5 root 2 whole square. I think
Yes, sir.
I think directly we can keep it as 50.
Hmm.
Similarly, E2 is equal to K times charge is plus 6. Again, distance square is 50.
Yes, sir.
Fine. So K is same 3 and by 50 and micro is also same. In E1 minus E2, I'll get 1 minus 2.
Yes, sir.
3 minus 6 is minus 3, right?
Yes, sir.
So first I'll write here E1 minus E2 is equal to, let me take 3 into 10 power minus 6, which is micro, okay,
Hmm.
and also K, and divided by 50. I'll take all of these outside, okay,
Yes, sir.
because they are common in both. 1 minus 2. This is 1 minus 2,
Yes, sir.
right? Similarly, E1 plus E2, E1 plus E2 is equal to, I just have to add these two, right?
Yes, sir.
Is this correct? Uh,
Sir,
Sorry,
but I still doubt that how can it be 45 degrees? It depends.
I'll come to that. See, we have E1 here, we have E2 here. We just have to add these two, right?
Yes, sir. It will be of 1 plus 2.
1 plus 2 divided by 50 into 1 plus 2.
Yes, sir.
So basically my E1 minus E2 will be minus 3k by 50 into 10 to the power minus 6. Fine.
Yes, sir.
And E1 plus E2 will be 9k by 50 into 10 to the power minus 6. Is this clear?
Yes, sir.
Now substituting in this equation, I will get E bar net is equal to, I have 1 by root 2 outside, so I need to take 1 by root 2 common, right?
Yes, sir.
Then I have E1 minus E2 I cap. So see here again, I can take 3k by 50 into 10 power minus 6 common from both.
Hmm.
Right? I'll write this as E1 minus E2. I'll write this as E1 plus E2. I can take 3k by 50 into 10 power minus 6. So 3k by 50 into 10 to the power minus 6. I have taken common. E1
Hmm.
minus E2 is just this with a minus sign, correct?
Yes, sir.
So that becomes minus I
Right.
cap. And
Yes, sir.
E1 plus E2 is this. Basically, I have a 3. 3 into 3, 9.
Hmm.
I'll have a
Plus
3j cap.
3 sir.
Simply plus 3j cap. This is the final answer. Let me explain to you right from the beginning. Okay? So first I'll explain the question, then I'll explain the solution. There are two charges placed at 2 points 0 comma 0 and 10 comma 0. Charge at 0 comma 0 is 3 microcoulomb. Charge at 10 comma 0 is 6 microcoulomb. Find the net resultant electric field at a point 5 comma 5, okay, due to these two charges.
Yes, sir.
So what how we started off was, first I geometrically figured out where is this 5 comma 5, and I constructed this isosceles triangle, right?
Yes, sir. I understood now.
And
Yes.
from that geometry I got this as 45-degree.
Yes, sir.
Now I'm going step by step, because next
Yes.
question also I'll give you more or less the same. I want you to do it, okay?
Yes, sir.
After this geometry which I have finished drawing, I need to specify that these charges are different, therefore the magnitudes of electric fields will be different due to the charges.
Yes, sir.
So I can't write E and E, I have to take this as E1, I'll take this as E2. The only symmetry that I have is the geometrical symmetry, which is telling me that this angle is 45-degree. That telling me that this angle is 45-degree is helping me where? Is helping me in writing the vector format of this particular field.
Yes, sir.
Therefore, I will write what is E1 bar in terms of I cap j cap, cos 45 I cap plus sin 45 j cap. What is E2 bar? Minus cos 45 I cap plus sin 45 j cap. Correct?
Yes, sir.
Then
Sir, can't we take E and 2E? I mean, because 3 microcoulomb and 6
6
microcoulomb should be.
microcoulomb. You can take it as 2 E and 2E also. No problem.
No, 2E and E.
Understood. If you
Yes,
take
sir.
this as E, that will become 2E,
Yes, sir.
because this is 6. 2 into 3.
When we know the angle, we use that resultant formula, so we get the direct result.
You can do that way also, but it is, as I said, it is always better to solve in terms of I cap, J cap, because
Yes,
you'll
sir.
get the
In this case, we
magnitude.
know the angles.
No, the same question you can solve E and 2E. No problem.
Yes, sir.
You can solve E and 2E. So basically, what you're saying is here you will write E, here you will write 2E. But I cap, J cap will remain the same.
Sir, I mean, we know that E square plus 2E whole square.
I understood. You want to
Yes,
substitute
sir.
it in a square plus b square plus 2ab cos theta. I
Yes, sir.
told you that it is always important. It is always very important and easy for us to get things in terms of I cap j cap, because you don't have to solve for direction of the resultant separately. You will get the
Yes, sir.
magnitude and direction all together, you will get it in one particular solving. And the practice
Yes,
of
sir.
solving in terms of I cap and J cap is helpful in other chapters, many applications, many places. That's also one of the reason why I usually come to I cap J cap. It's not like solving it with resultant formula is something wrong. No, it's okay, it's absolutely okay. But why I make people practice more of ICAP, JCAP, ICAP, JCAP is that so that you guys get acquainted with ICAPs and JCAPs and KCAPs, which makes your life more easy in all other chapters.
Yes, sir.
Then you will see that. So basically, we did not do any electrostatics per se in the electric field is kq by r square magnitude.
Yes, sir.
So that's the only information from electrostatics that we have used over here. Rest all what we have actually done is vectors, identifying school geometry, identifying this is 45 degree. Therefore, because I know vectors, I'll write it in terms of I cap, J cap, and vector, 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 vector. That's it. Also, I'll
Yes,
tell
sir.
you here only, if you look at this step, it becomes way easy if I write it in terms of I cap, J cap. And it
Hmm.
becomes way difficult in this step only if I use the a square plus b square plus 2ab cos theta, because I'll get another step over here, tan alpha is equal to b sine theta by a plus b cos theta. Then we don't know where that direction is, what it is and all. I don't want to fight it out so much. I just want to solve it in a very simpler way so that I'll come to the final answer easily. Now, if that fellow will ask me what is the direction, from here I will figure out. It's a faster way of solving also, right? I'll give similar question one more. I think one mistake that you've done is you've taken both of them as E and
Yes, sir.
cancelled the horizontal components, put a J cap right over there. No problem. So there has to be uniformity in how we are solving while we are solving. In all three subjects, it's useful: maths, physics, and chemistry. So while we're solving, even if it's the most obvious question, most obvious seemingly question, you should never go just jump the gun. You should always read the question in a uniform speed, solve the question in a uniform speed. So this is what happens when you ask me a doubt. I don't jump right away with the solution, even if I understand it, right? I
Yes,
go
sir.
slowly, step by step in a uniform way. So while solving this, I learnt it when I was preparing for my entrance exam. While solving, we have to maintain a uniform speed in while reading the question. So while reading the question, there are two things that you're doing. You're reading the English that is present over there, simultaneously start figuring out what the information is. So two
Yes,
things
sir.
are, so you're dissecting the information that is given, trying to solve a little bit mentally and all, and you're also reading English. There is a probability of going wrong in that situation. That's why uniformly read the question while you're figuring it out, also making sure both are happening correctly. Next,
Yes, sir.
as soon as you read a question, the next thing is draw a figure. In physics, draw a figure. All chapters, maximum 95% chapters, draw a figure to the best of your possibility. Because once you draw a figure, more or less the question is solved. If your figure is wrong, there's no point solving. If your figure is right, your 30 to 40% of solving is done in that only. Especially in
Yes, sir.
chapters which have vectors, it's even more. Once you draw the figure, then you start solving. While solving also, no speed variations and all. Uniform speed solving. Once you jump to the calculation part is the last thing that we do when we solve problems. So when you're substituting and trying to calculate, again there is a uniformity in that, but you do most of the things in your head. So we will come across when the things will come up. I'll show you how I calculate. Okay,
Yes, sir.
fine. 20th question, I am giving you a similar question. I am changing the coordinates and the uh, charges also. So let's take the coordinates as minus 3 comma 0 and 7 comma 0. Charge placed, let's say this is point A and this is point B. Charge placed at point A is plus 5 microcoulomb and charge placed at point B is 15 microcoulomb. Now find the electric field at a point 2 comma 5. Find the resultant electric field due to both the charges in terms of I cap j cap at a point 2 comma 5. Okay. See, earlier you said that let us take, because this is 5 microcoulomb and that is 15 microcoulomb, and if you see this isosceles right triangle is also the same as previous.
Yes, sir.
So like previously, like you suggested, I can take the magnitude. If I take this fellow as E, this fellow will be 3E.
Yes, sir.
Now angle is 45 degree like the previous question.
Yes, sir.
So I'll just write E1 bar is equal to E times cos 45 I cap plus sin
Yes,
45 j.
yes, sir.
So I'll take 1 by root 2 outside, I cap plus j cap. Correct?
Yes, sir.
Good. E2 bar, I should write it as what? 3e
3 by root 2
root 2
into I cap minus I cap plus J cap. Yes, sir.
minus I cap plus j cap. Is this clear?
Yes, sir.
Is this correct?
Yes, sir.
Sure. Okay.
Yes, sir.
So simply we have resultant vector as, we can have e by root 2 common, correct?
Yes, sir.
I have I cap minus 3 I cap,
Yes, sir.
which is minus 2 I cap, correct?
Yes, sir.
J cap plus 3 J cap, which is plus
Plus
4
4
J cap.
J cap. Yes, sir.
So I think your answer is right. Let's check it. So I'll get root 2 here. I'll get minus I cap plus 2 J cap.
Yes, sir.
What is E? E is equal to K times charge due to
K,
5 microcoulomb,
K into 10 power minus 7.
correct? 10 power minus 7,
Yes, sir.
correct? So K into 10 to the power minus 7. So simply my E net resultant vector, I can write it as K root 2 into 10 to the power minus 7 times minus I cap plus 2 J cap. Is this clear?
Yes, sir.
You got the same thing?
Yes, sir.
Good.
I got
So let me solve this question. And just take a look at how I am solving it. Okay.
Yes, sir.
So I have x axis, y axis. I am not taking any values over here because
Yes, sir.
I want to solve this question as a general purpose question, so that later on, anytime you get any questions like this and there are values, you can figure out how to solve it. Okay. So let us take a point over here minus a comma 0.
Yes, sir.
and let the charge at minus a comma 0 be q1, and let us denote this point capital A. Okay.
Yes, sir.
Let us take another point B as b comma 0, and let the
Yes, sir.
charge over here is q2.
Mm.
For easy purposes, although when it comes to numericals, I will solve one numerical on this, and I will take the point where we want the electric field somewhere else. For right now, for easy purposes, let me choose a point C and let the coordinate of it be 0 comma C. Okay.
Yes, sir.
One important factor is these two are positive charges. That information has to be given.
Mm.
So what do we have to find? Find the resultant electric field at point C due to charges E1 and E2. Okay.
Yes, sir.
Now, first thing what I said, we will draw the geometry, connect these two. Okay. Then connect
Yes, sir.
these two. Okay. Now the idea is, because both are positive charges, the electric field due to charge q1 at point C will be in this direction, and I will take that as E1.
Mm.
The electric field due to that charge is E2, and I will take it like this. Fine.
Yes, sir.
Till here we are doing it the same way that we have done previous question.
Mm.
Now let this angle be theta 1. The angle
Yes.
E1 makes with x-axis, let it be theta 1.
Mm.
And let this angle be theta 2. Okay.
Yes, sir.
The values of theta 1 and theta 2 can be anything. Let angle made by E1 with positive x-axis is theta 1. Angle made by E2 with negative x-axis theta 2. Okay.
Yes, sir.
Now let us write the vector form of these in terms of I cap and j cap. So E1 bar is equal to magnitude is E1. How will I denote the unit vector making an angle theta 1 with x-axis? Cos
Cos theta 1
I
I cap
cap plus
plus sine of 90 minus.
sin theta 1
No, 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 no.
j
Sine
cap.
theta 1. Yes, sir. Yes, sir.
Okay.
Yes, sir.
That's why I said vectors is very important. I told this to you long ago. Right? Done?
Yes, sir.
Now, E2 bar. What is E2 bar? E2 times, tell me.
Minus cos theta 2 I cap
Good. Minus cos theta 2 I cap
plus sine theta 2 j cap.
plus sin theta 2 j cap. We are only doing vectors.
Yes, sir.
We are saying that we are in electrostatics, but it's a joke. We are doing vectors. Cos theta 1 I cap plus sin theta 1 j cap. This fellow is cos minus cos theta 2 I cap sin theta 2 j cap. Clear?
Yes, sir.
Magnitudes are E1 and E2. We will figure out the magnitudes later. Okay.
Mm.
Now,
Yes, sir.
so therefore, the resultant vector E bar net is equal to E1 bar plus E2 bar, which is equal to, if I will write the summation of these two in terms of I cap and j cap, I'll simply have E1 cos theta
Cos
1,
theta 1
yes,
minus E2 cos theta
minus
2
E2 cos theta 2
I cap
I cap plus E1
sine theta 1
plus
plus
E2
E2 sine theta 2 j cap.
j cap. That's it.
Yes, sir.
Now I want to find what is E1. E1 is equal to K Q1 by
A square under root A square
this is basically this is A and this is C,
C
right?
under root A square plus C square.
Under root A square plus C square. Similarly, what is this fellow? This is small b under root
6 units. So that was B. I thought it was 6.
okay
Under root B square plus C square.
under root b square plus c square. Clear?
Yes, sir.
So E1, what should I write? KQ1 divided by what is the distance square?
A square plus C square.
Good. A square plus c. Similarly, what is magnitude E2? KQ2 by
AQ2 by B square plus C square.
perfect. Similarly, if you understand now school geometry, if the angle made by E1 with x-axis is theta 1, then the angle made by this connecting line with x-axis is also theta 1.
Yes, sir.
Correct? Similarly, if the
Corresponding.
angle made by E2 with negative x-axis is theta 2, then the
That is
angle
also.
made by this is also theta 2.
Yes, sir.
So what I am trying to say is that from this figure, we can get what is cos theta 1. What is cos theta 1?
A by A by under root of
A
A
by
square.
under root of a square plus c. What is sin theta 1?
C by under root of
C by under root of a
A
square plus
plus
c. What is cos theta 2?
B by under root of B square plus C square.
B square plus c square. And sin theta 2 is
C by under root of B square plus
c by under root of b square plus c square. So the idea is in our E net resultant, E1 cos theta 1, E2 cos theta 2, sin theta 1, sin theta 2, we know everything.
Yes, sir.
We just have to dump it in that, right? So now I'll write it here directly. E net resultant vector is equal to E1 cos theta 1,
Yes, sir.
E1 cos theta 1, A Q1 A by A square plus C square
power 3 by 2.
whole to the power 3 by 2. Fine?
Yes, sir.
Minus E2 cos theta 2.
KQ2 B
KQ2 B divided by
B square plus C square whole power 3 by 2.
3 by 2. And this is all I cap.
Yes, sir.
And I also put the minus.
Yes, sir.
Okay?
Yes, sir.
Plus E1 sin theta 1
KCQ1
divided by
A square plus C square power 3 by 2.
A square plus C square whole to the power 3 by 2. Plus, here we will have plus sign.
Yes, sir.
E2 sin theta 2.
KCQ2
KQ2C divided by
B square plus C square
whole
whole
to the
power
power
3
by 2, and this is my J cap, and this is my E net resultant.
Yes, sir.
Is clear?
Yes, sir.
Wait.
Sir, do you even use this anywhere?
Wait a minute. No, that's why I said wait. We never use anything as a particular formula or anything, right?
Yes, sir.
What I am trying to show you is after your exams and stuff, Once you practice this thing without seeing, you will not face problem in finding electric fields or finding forces due to point charges in a Cartesian plane.
Yes, sir.
If once you reach to a stage where you are able to solve this all by yourself without seeing, drawing the entire figure, understanding theta 1, theta 2, giving it theta 1, theta 2 by yourself, writing it in terms of I cap, J cap clearly, adding them, finding out what they individually are, substituting without making any mistake, and getting the right answer. If you're able to do the entire thing that I have done right now, you will never face a problem in point charges, force, or field in
Yes, sir.
Cartesian system. Clear?
Yes, sir.
Another thing is that question that I have given is using the Cartesian system, but one important thing in between is, forget about this solution and all for now. If you are given charges q1 and q2 anywhere,
Mm.
not mentioning any Cartesian story, you will definitely draw E1 and D2 because the field lines for positive charges will be away from them.
Yes, sir.
From there, your own Cartesian, if you draw, suppose no Cartesian is given to you, but from here you draw your own I cap and J cap. This is my I cap, this is my J cap.
Like they give angles of A and B.
From here, if you start your own Cartesian and say let this angle be theta 1, this angle be theta 2,
Yes, sir.
then you can also see that the resultant is E1 cos theta 1 minus E2 cos theta 2
Yes, sir.
in terms of along x-axis, and along
Mm.
y-axis E1 sin theta 1 and E2 sin theta 2 are adding each other.
Yes, sir. Yes,
Most
sir.
understood.
Yes, sir.
Most of the questions I solve it those that way only, directly writing these two. And if
Mm.
I want, if see also, if you want the angle made by the resultant with x-axis, you will simply tan alpha is equal to this divided by this,
Yes, sir.
all those things.
Sir, then how do you know which side is greater?
I don't want to know.
Sir,
Let
in the
that come
sine
as
theta
negative.
components, we need to subtract it. So,
Sine
how do you?
thetas, sine thetas and cos thetas, all the thetas that we've taken are acute. They will
Yes,
be
sir.
positive.
Sir, I mean, we are subtracting that E1 cos theta 1
I
minus E2
know.
cos theta,
I'm coming to that.
whatever.
I'm
Yes,
coming
sir.
to that. Your problem is, what if I have a minus sign, then what? Let it come as minus. 1
Yes, sir.
minus 3, I'll get minus 2. That means it is minus 2 I cap. Or I just have to adjust my mindset to that. That's it.
Yes, sir.
Suppose there are two vectors. Here I'll show you what I'm trying to say exactly. Suppose there are two vectors A bar and B bar. One important factor that we have to understand is this vector is of the form of some kind of a force or some kind of a field. Why am I saying that? If these two vectors are velocity vectors, I can't add them. First of all, one particular object cannot have two velocities.
Yes, sir.
These things happen only when there are forces, fields, or something like these which can occur simultaneously.
Yes, sir.
So this is a vector which can be added, is what I am saying.
Hmm.
Because electric field is effect. Suppose one friend of mine is pulling me with 5 newtons in this direction, another friend is pulling me with 10 newtons in this direction. These effects can be vectorially added. They have a
Yes,
property.
sir.
Correct? Understood?
Hmm.
So in that scenario, when you give me two vectors A bar and B bar, that means I know I can add them vectorially. What is the easiest way I can do? The easiest way I can do is, I will choose this fellow as my origin, this as I cap, this as J cap, and name my own angles. Let us say this angle is alpha 1, this angle is alpha 2. I put those angles acute for a purpose so that all the sines and causes will be positive.
Yes, sir.
Now, if I want to write the resultant of this, how will I write? I will simply say A cos alpha 1 minus B cos alpha 2, correct?
Yes, sir.
A cos alpha 1 minus B cos alpha 2, but this is in along x-axis, so I cap.
Hmm.
A sin alpha 1 plus B sin alpha 2 in j cap.
Yes, sir.
Sin alpha 2 j cap. One more thing I will tell you. When the magnitudes of these two were same, that became 0. That means the horizontal directions got cancelled and everything was in the vertical direction.
Hmm.
That happens, you have seen it in the last class.
Yes, sir.
So what I am saying is what we have done in the last class is one of the cases of what we have done just now.
Yes, sir.
Where these two are equal, they will cancel and everything else is in the j cap.
Yes, sir.
Is this clear?
Yes, sir.
Xerox.